of current source inverter also used for speed control of induction, different type of AC motors. Now I am discussing three-phase full-bridge voltage source inverter in two level. This is the circuit diagram. Here it is connected with a load that are considered. Suppose you are considering R, then the in case of there are two mode is possible. One is 120-degree mode, another is 120-degree mode. Actually, 180-degree mode, three switch will be on at a time. Either one switch from out of top, other will be or other will be lower, and or two switch from out of topper and one switch from lower. In this way, it will be on. What the switching sequence will be, we have to considering. Suppose 1 2 6 1 2 1 2 3 2 3 4 2 3 4 3 4 5 5 3 4 5 4 5 6 and 5 6 1 and 6 1 2 again. Actually, how many switches? Six switches. Six switches will be conduct 360 degree. One switch will conduct 60 degree. Then 180 degree. That means three switches will be conduct at a time. That means upper you have to consider one switch and lower you have to consider two switches. Or upper leg you have to consider 135 is known as upper, top leg, and lower leg, bottom leg it is 462. So that means this is the switching sequence. When the suppose we are considering the 6 1 to 1. First of all, BNO we have to considering BNO equal to one third BAO BB plus BCO, and then everybody knows that BAO BBN BN. Then at 6 6 1 2 is on. When 6 1 2 is on, that will be the way 6 2 2 6 6 2, then it will be going to 1. Similarly, that time the voltage you are getting BAN 2 BDC, 2 third BDC by 2 third BDC, and similarly BBN and BCN will be minus one third BDC. That why? Because it will be that summation of the BAN plus BBN plus BCN equal to 0. That means the balancing condition is possible. In such a way, I have prepared one table for conduction and the voltage you are getting 612. This is the table, and 1 2 3 2 3 4 3 4 5 4 5 6 5 6 1. That will be the BBO and BCO. From here you are getting. Similarly, BAN BBN and BCN, we have to find out the summation of this at 0. Now we have to drawing here B2 by 3, then you have to considering B2 3. After that 1 2 3 is on, then one third BC, then it will going to one third BCC. After that minus one third BC, minus one third VDC. In such way, I am drawing BAN, BBN and BCN. Okay, this is the line to neutral voltage waveform. And similarly, when 6 1 to 1, we have to write BAB, line to line voltage. BAB equal to BAN minus BBN. Then you will get BDC, BBC, BCN. Then you will get this one 0. Similarly, we have to find out what 1 2 3 2 3 4 3 4 5 4 5 6 and 5 6 1. This will be the table. We have to find out the voltage, line to line voltage, and this is the waveform across the line to line voltage we are considering for the above table. Now, uh, when we are considering 120-degree mode, when we are considering 120-degree mode, then there two switches will be one from upper leg and one from lower leg, or one from lower leg, one from upper leg. How to? It will be 6 1 because of I already told now one switch 60 degree, two switch it will be 120 degree. Then 6 1 1 2. 2 3, 3 4, 4 5, 5 6, and 6 1. This will the way. Now, in this way, we are getting the output voltage. That means when when 1 and 2, 6 and 1 will be 1, then 1, this leg, this will be taken. That means A, BAN, it will take half voltage. Then 6, BBN, it will be take minus half voltage, BDC. So in this way, we are getting half voltage DC and half minus of BDC. Similarly, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, we are getting the voltage, and that voltage I am preparing this table, and this is the line to neutral voltage, and this is the waveform I am drawing same way, and this is the line voltage I have they find out, and this is the line voltage waveform. This is the edge bridge topology with the single DC link. The edge bridge, this is also used for the HEB, and there are six both six switches are connected with a link, DC link. That means we have to considering that the this one side converter will be on topology. That topology will be known as just like as a edge bridge topology, and it will be getting you can also convert this one control as a 180-degree mode or 120-degree mode also, and you also use in PWM mode also. Now, DC resonant DC link inverter, we are considering here L and C, for resonant component to control the inverter, and that means this inverter input voltage pulsating by adding parallel resonant network between DC voltage source and the inverter bridge. Therefore, the link voltage has zero crossing, which create the desirable ZBS condition of the inverter. What is the there are this also used for the electric vehicle, and this is also active clamp that means the resistance also capacitor also, there are two capacitors used for clamping purpose. The what this, there is major advantage of RDCL. That means minimum number of power devices and elimination of Sinavar. ZBS is main switches, low dB by dt of motor terminals. These are the advantages. And auxiliary resonance in our inverter, this is also we have to use everywhere we are connected the switch. That means we are 1 2 3 switch are connected with a leg, three legs. There are the advantage of this. Now zero current transition inverter also we are connected here, six switches JST inverter, that also used for the electric vehicle system to control the motor. This is the impedance source inverter. That impedance source means is impedance source. Here we are considering J source. This one is J source, and this is voltage, and this is three-phase inverter. Okay, that at the J source are used. Now I am discussing another important two-level inverter. Is there are disadvantage of two-level because there are so many harmonics also, and high distortion low, okay, and high dB by dt. So multi-level continue to receive the more and more attention because there are high voltage operation capability, low switching loss, high efficiency, and good electromagnetic interference. Nowadays, multi-level inverter become increased popular to the in power application as multi-level inverter have ability to meet the increasing demand power, and this is also a multi-level inverter several advantage over the two-level inverter. That is the they can generate output voltage, extreme low distortion and lower dB by dt. They draw the input current with very low distortion, generate smaller common mode voltage, and they can operate lower switching frequency. That there are different topology of multi-level inverter: diode clamp or neutral clamp, and class capacitor clamping or flying capacitor, and cascade edge bridge multi-level inverter. So this is the multi-level classification of multi-level inverter. We have to considering the common source, and I already told, and separate sources. This is simple one leg, one phase leg. We have to n level. We have to considering the connected with the switch and capacitors BN, BBN, B2. We have to connect it B1, B2 in such a way. Now, three-phase diode clamp multi-level inverter. I am discussing three-phase three-phase diode clamp multi-level inverter. The most commonly used multi-level topology diode clamp, which is diode are used clamping for here. So how to decide the level voltage level? Suppose voltage level is 3. So active switch, this active switch will be 12, 6 m minus 1. That means 3 minus 2, it will be 12. Similarly, clamping diode, it will be 3 into m minus 1, m minus 2. Then it will be 6. And DC capacitor, it will be m minus 1. That means 2. Similarly, when you have to considering 4, it will be connected that number of switches and diode and capacitor in such way. 5 level, 6 level, 7 level. By increasing the number of voltage levels, the quality of output voltage is improved, and the voltage waveform becomes closer sinusoidal waveform. This is the main and these are phase 1, phase 2, and phase 3 are connected with a load. Load means you have to connect a motor. The advantage of the diode clamp: a large number of level n, a small harmonic distortion. All the phases are share the common DC bus. Reactive power flow can be controlled, and there are some disadvantages also. Different range of clamping is required. That means power flow difficult because of the capacitor in imbalance. Okay, this is the three level flying capacitor inverter. This is this is also we have to choose three level. It will be 12 active switch, clamping diode 0, and capacitor m minus 1 3 into m minus 2 summation by k equal to 1 into k. So we are considering in such a way. Then the capacitor also we have to consider. Now this is the advantage of that. I will not discuss. These the cascade has this. This is also used for the HV hybrid vehicle systems, or that also this is also separately voltage source is given. Three level cascade. This is also we have to considering level and active switch and DC source also. These the advantages. Now I am discussing very important thing, the battery charger. So EM battery charger can be classified on board and off board with the unidirectional bidirectional power flow. Unidirectional charging limit to the hardware requirement and interconnection issues and tends to reduce the battery degradation. Now a bidirectional charging system support the charge to create battery and inject back to the grid, and the power stabilization with adequate the power conversion. So typical onboard charger limit the high power because the weight, space, and cost constraint. They can integrate it with the electric drives to avoid the problems. Onboard charger system can be conductive or inductive. The inductive charger transfer power magnetically. Now, this is the general unidirectional or bidirectional topology we have to consider for the charging. So actually, we are considering here the AC to DC converter or AC voltage you are considering. AC voltage you are given the here the input filter, then AC to DC converter with filter, the then it will be the DC link capacitor. Then DC to DC converter is bidirectional DC to DC converter connected with the battery pack. Then battery it will be changing charge the battery, it will be charge the battery. So what is the difficulties of that? Actually, we are using the circuit will be more lengthy and complexity because of that means in AC to DC converter also using. Suppose in case of control rectifier it will be used, or control rectifier AC to DC control. Then the thyristor angle, firing angle, control the firing angle of thyristor. It is more, it is difficult, na. So that is why then the output voltage of the AC to DC converter it will be will not get proper. Then the DC to DC converter, that means charge it is bidirectional, it will be also maybe problem. Now, on and off board charging system of power level electric vehicle system. So there is given total layout when we are using PEB or plug in electric voltage. So that means we are considering on and off board. That means grid to connected here on board charging. Then that means we are considering that charger. Then AC to DC converter, and this will be the uh, voltage charger. That means on up on, and then it will be flow of the power. The power flow will be the bidirectional. It may be also unidirectional. It when battery charger are not considering on this side. And now DC to DC converter is bidirectional also use here and the battery back. So battery it will be charge the battery when it is necessary to control the DC to DC converter. Then battery will give the backup to the DC to DC converter. And similarly, that also light for the case electronics load, and that case is also. And this is the DC to AC converter. DC to AC converter are control the electric motor. I already discussed. And again, that total whole charging system are considered. Now, another is full bridge series resonant charger, that are charging system level. There will be we are considering that this is the rectifier, and this is the power factor correction circuit, and this is EMI filter. Filter are using for the that filtering the AC voltage, and it will be into the rectifier. Rectifier it will be sent to the power factor correction. That power factor correction will be controlled to the bridge. It will be unidirectional and DC to DC converter. That means the isolated it will be considered. That side is known as on off board, and this side we are considering as a on board. And battery is given here. Now, this is the isolated two coordinate charger. That also I already discussed in two coordinate or converter. That is also bug and boost converter. This is class A or class B chopper also you can say, class A and class B converter, that will be connected. And then in this way also you have to the bidirectional charging system is possible. Now we are considering the isolated bidirectional at bridge converter. This is similar to the I already discussed this. This is the similar, and this side is off board, and this side we are considering a on board. Now, there is the power factor correction stage. A power factor PFC power factor correction stage usually placed between the rectifier and DC to avoid the harmonics to grid as well as to stabilize the DC link voltage. So there is we are considering rectifier, and then we are considering this PFC to the load, to the load. That means it will be using for the power factor correction. Now another charger we have to use for integrated charger. The function can be integrated if charging and traction are not simultaneous. In an integrated charger, motor winding used for filter inductor or an isolated transformer, and the motor drives inverter serves as a bidirectional AC to DC converter. The most important advantage is that low cost, high power bidirectional fast charger can be supported unity power factor. A combination motor drives battery charge system based on the inductor and currently used Ford Motor Company, an isolated integrated charger based on split winding AC motor will be used for the automotive industry. Okay, so there are also some application electric scooter and that one. So now this is battery pack and DC to DC converter and three phase inverter is winding switching. That is the three phase inverter or switching or winding switching devices also uses. And this is the electric motor, and that will be the charger will be we have to consider in this one. Now another charger is inductive charging. Conductive charger use the metal to metal contact as in most application and electronic device. But I think inductive charger of EVs is based on the magnetic contactless power transfer. And inductive charger transfer power is powered magnetically. This type of charger has been explored level 1 and 2 devices. That the advantage of that contactless charging inconvenience user instead of deep cycling the battery, the vehicle battery can be stored of frequencies and parked at home, at work, when shopping, and the traffic signal also. It is possible to build the charging strip highway which enables the charging while driving. Now, this is the typical inductive coupling EV battery charging system. Here we are considering the AC to DC conversion. This is on-board, off-board infrastructure. That means main frequency conversion DC to AC. Then the coupler are used, and then charge point, the secondary side, it will be considered, and this side is on board and AC to DC, and this is the DC bus capacitor, and then the battery charger pack. That charger battery pack, that also when it will be fully charged, then it will be considered as similar way DC to AC, and in this way that will be bidirectionally. Another is wireless charging. Wireless charging involves the use of power and energy transfer much longer distance. It is different from inductive charging. Involves transformer and coilly placed in primary and secondary winding. Although inductive charging eliminates the direct contact, and wireless charging could eliminate the cable and plug all together, and it provides the safest approach the electric battery charging. And there have been a few different experiments carried out and that wireless energy transfer. And in this setup, also we are considering this stuff per car, and then we have to given the charge that then successful deployment of EVs next decade, depending the following condition is necessary. Following condition, my solution are given: charger reliability, safety consideration, and EVs charger efficiency, reducing charge cost, and sustainability B2G bidirectional, and that means and charging strategy, setting limit the charging time and access tools. Okay, this is my presentation.